Guys, Miss Smith here for part 3 of our topic D, Module 2, 3rd grade study guide review. We have gone over strategies for adding and subtracting in part 1 and part 2. So if you're looking for those strategies, that's where you will find them. The last video, we are discussing how to tackle multi-step story problems. Okay, so we just read the story problem first. It said post offices sell stamps and postcards. One post office sold 109 more stamps. So we discussed that we are talking about two different pieces of information. I have stamps and I have postcards, and there were more stamps than postcards. So I need to keep this straight in my brain. I wrote above stamps more, and I wrote above postcards less. Then it continued to say, we sold 416 stamps. Now, I know that I sold a total of 416 stamps, but just a minute ago, it told me that that was 109 more. More than who? More than postcards. That means postcards have 109 less than stamps. If stamps sold 416, then postcards are 416 minus 109. It's tricky, but that's the way they word these problems. The first step is we have to figure out how many postcards we sold. We're going to use a strategy. Okay, 416 minus 109. We've talked a lot in part 1 and 2 about not trying to just subtract unless they really understand what they are doing. We don't have enough here to take away 9. So we're going to draw those place values to understand what's happening. We have 100s, we have 10s, and we have 1s. 400, 110, and 6 1s. These are hundreds, 100, 200, 300, 400, 10, 11, 12, 13, 14, 15, 16. Okay. I do not draw this because I am not getting more. Instead, postcards are 109 less because stamps were 109 more than postcards. So the opposite is also true. I don't have 9 to take away, so I have to borrow it from his neighbor. He goes from being a 10 to 10 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We talk about if I am using traditional or standard algorithm, I have to rename. I no longer have 6 in the 1s place. Now I have 16. I no longer have anything in the 10s place. I have 0. The next thing is I need to look, do I have enough to subtract from my 1s? Do I have enough to subtract from my 10s? Luckily, I didn't need to take anything away, so I don't have to also borrow from my hundreds. Now I can take away. 16, take away 9. I'm going to take away 1, 2, 3, 4, 5, 6, 7, 8, 9. That leaves me with 5, 6, 7. 16 take away 9 was 7. 0 take away 0 is, of course, 0. And 4 take away 1 would leave me with 3. Now then, here is the other thing that is crucial. A lot of students on a multi-step problem are bright enough to make it through the first part, and then they think they're finished. But we need to continue reading what is the question asking. We know now that we've sold 307 postcards, and we know we sold 416 stamps. The question they're asking is not how many postcards, but it says how many stamps and postcards did the post office sell. So we then have to put together the amount we just found with the original amount they gave us. We have 416. We're putting it together with 307. Okay? Just to break up the monotony a little bit, I'm going to do it down here with adding like units first. That still is a go-to for many of our students. They learned it in second grade with two-digit numbers. This represents 400. This represents 10. This represents 6. This represents 300, nothing, and 7. Okay, so I would put together my 400 plus 300 to give me 700. 10 plus nothing would be 10, and 6 plus 7 would be 13. I would then put together those last 10s to make 20. I still have 3. I still have 700. And when I put all of that together, I have 723 postcards and stamps that were sold. Okay? If they prefer, they can use the traditional algorithm. But again, we recommend that if they're doing this, they also draw the place value just to double check their work. 100, 200, 300, 400, 10, 11, 12, 13, 14, 15, 16. And this time we are going to draw the additional amount because we're getting more. 100, 200, 300, nothing here. 1, 2, 3, 4, 5, 6, 7. Okay, adding up those amounts. Here is where you can either do the entire total and then add those totals together, or if you want to do it more like this traditional algorithm, you're going to bundle every time you get 10, or you're going to carry the 10 into the correct category. Here we clearly have 5 here and 5 here that make 10 together. So we're going to give ourselves an extra 10. We have 10, 11, 12, 13. The 3 goes here. The 10 I just made goes in the tens column. Now I have 10 plus 10. 1 plus 1 is 2 tens or 20. Don't need to rebundle anything there. And I have 400 plus 300, which would give me the 700. Either way, we come out with the same answer. So again, your child may use any strategy they would like that makes the most sense to them, but we want to focus on being organized, thinking about what do those digits actually represent. Are they hundreds, tens, or ones? And what is the question asking me? I hope this helps, and happy studying.